everybody. אני אדבר באנגלית. אני מקווה שזה טוב לרון. אני יכול לדבר בעברית, אבל לא טוב כל כך. אז אני חושב שזה יותר טוב בשבילכם שאני מדבר אנגלית. So, יחי אדוננו מורנו ורבנו מלך המשיח לעולם ועד. יחי אדוננו מורנו ורבנו מלך המשיח לעולם ועד. יחי אדוננו מורנו ורבנו מלך המשיח לעולם ועד. I want to thank Professor Silman and Rabbi Dubnik for inviting me to speak today. They do amazing work. It's 26 shanim kavar, mamash mashahu. So our theme tonight is science, war, and peace. And indeed it is written in Daniel, in chapter 2, as well as in Bereshit Rabbah, that Israel is destined to suffer 4 bitter exiles. Arba Galut, Bavel, the Persian exile, Persian and India, the Greeks, and Rome, through which we're still suffering now. Moreover, the Zohar in Parshas Bashalach in volume 2, page 58b, says, Rabbi Abba said in the name of Rav Yosef Saba, and so said Rabbi Shimon, in the future, the Blessed Holy One will revive all those kings who besieged Israel and Jerusalem, Andrianos, Lufinos, Nebuchadnezzar, and Shancherib, and all the rest of the kings of the nations who destroyed his house, and cause them to reign as before. And all the nations will gather with them. And in the future, the Blessed Holy One will exact retribution from them openly around Jerusalem. So all the kings who destroyed us are going to be revived, are going to come back, and are going to try to destroy us again. So it is well known that Saddam Hussein, Yirmach Shemo, openly declared himself to be the reincarnation of Nebuchadnezzar, the Babylonian tyrant who destroyed Jerusalem and raised the first Beis Hamikdash. He spent a fortune rebuilding the ancient ruins of Babylon and inscribed his name on each and every brick, just as Nebuchadnezzar had done. During the course of the dig, this is a picture of one of the bricks that Saddam Hussein made for himself. During the course of the dig, archaeologists uncovered a plaque on the ancient city gate proclaiming Nebuchadnezzar's greatness. Saddam ordered stonemasons to place another plaque on the opposite side of the gate, glorifying his own greatness. The statues he made of himself purportedly betrayed him standing and pointing in the direction of Jerusalem. See if this works. That's another brick that he did. All his statues, they were pointing in the direction of Jerusalem, which he dreamt of conquering, finally attacking Israel with 39 Scud missiles during the Persian Gulf War, miraculously none of which directly killed anybody. For example, him. Miracle after miracle, though they did a great deal of damage to many of the buildings they hit. Finally, he was found hiding in a spider hole, just as Nebuchadnezzar, bedraggled and disheveled, just as Nebuchadnezzar spent his final days, like a wild animal of the field. He was hung on the 9th of Teves and buried on the 10th of Teves, the fast day which we observe each year, commemorating the day Nebuchadnezzar's army first surrounded and besieged Jerusalem. Thus, we've already seen the first prophecy of the Zohar fulfilled. Now, it doesn't take great imagination to understand the second prophecy. Iran is the descendant of ancient Persia. And even today, we stand under the threat of Iranian aggression and its nuclear ambitions. In spite of harsh economic sanctions and international condemnation, Iran perversely persists in its nefarious efforts to destroy Israel. Hashem will no doubt see to it that it meets the same fate as all those who have persecuted the Jewish people. I skip now to the fourth kingdom. The fourth kingdom, which is not so hard to discern. The West, meaning the United States and Europe, as the descendant of ancient Rome, continues to this day to undermine and thwart the Jewish people from exercising full sovereignty over the land and holy places, all the while proclaiming its purported friendship. This too will ultimately fail with the re-revelation of the Rebbe, Melech Mashiach, and the building of the third Beis Hamikdash in its place, Tekef Yad Mamash. But the third kingdom, that of Greece, it's not quite so obvious to discern today. Although the Golden Dawn neo-Nazi movement I don't know if you're aware of it. There's a neo-Nazi movement in Greece. It's rather popular. They've gained, they currently have 7% of the vote, and there's populist nationalism is on the rise in the rest of Europe. The country of Greece as a whole has not represented much of a threat to modern Israel or today's Jews, at least not since the Second World War. Rather, I would suggest that just as during the time of Yehuda Maccabee and the Hasmoneans, it is the legacy of Greek culture, meaning polytheistic toleration, veneration of the human body in art, theater, sport, and spectacle, and the philosophical materialism and atheism of the academy that has reawakened and once again threatened the Jewish people. And nowhere is that battle currently raging more furiously than right here in academia. On college campuses across the globe, Jewish students are under both intellectual and physical threat. Israeli academics are often boycotted and shunned, and anti-Semitism has found fertile ground in which to take root. This is a war no less dangerous than one with live ammunition. Only the weapons are cultural and intellectual, and the battleground is the mind and soul and future of our people. Nonetheless, Yeshayahu prophesies that no weapon formed against you will succeed. And indeed, it is not generally appreciated to what extent the scientific developments over the last 100 years or so have thoroughly undermined the intellectual foundations of the Greek onslaught against us. Although Greek mythology and philosophy developed over a period of centuries, the legacy of Greek culture eventually came to include empiricism, rationalism, and a belief in the eternality of the physical universe and of its fundamental Platonic forms. Leucippus and his pupil Democritus introduced the concept that all matter is made up of tiny, indivisible, unchangeable, and indestructible solid particles, or atoms, from the Greek word atomos, meaning indivisible, which came in an infinite variety of different shapes and sizes. While these ideas held sway over the last 2,600 years or so, modern developments in science have shown each of these assumptions to be false, and often against the predilections of those who arrived at these innovations, have slowly revealed a universe consistent with the Torah point of view, rather than that of the Greek point of view. Moreover, this too was prophesied in the Zohar, as Professor Simon was just mentioning. For it is written in Parshas Noach, in the 600th year of Noah's life, in the second month, on the 17th of the month, on that day, all the foundations of the great deep burst forth, and the windows of the heavens were opened. That's Bereshit chapter 7, verse 11. The Zohar, in volume 1, page 117a, reads this verse as a prophecy. In the 6th century of the 6th millennium, 5500 to 5600, or 1740 to 1840, as Professor Simon mentioned, the gates of wisdom will open above, and also the well springs of wisdom below, preparing the world to be elevated in the 7th millennium, just as man prepares himself toward sunset on Friday for the Sabbath. The Rebbe Melech Mashiach explains in the Sikh of Parshas Noach, 5736, 1976, that the gates of wisdom from above refers to the revelation of the teachings of Hasidus and the dissemination of the Pneumius of the Torah, while the wellsprings of wisdom below refers to the scientific revolution and the understanding of the natural world. These two waters would begin to flood the world in the 6th century of the 6th millennium and would ultimately be revealed as a single continuum of divine knowledge. As Rabbi Akiva said to the four who entered Pardes, when you come to the place of pure marble stones, do not say water, water. For as the Zohar, volume 126b explains, the two waters are one, upper and lower. Upper Yud and lower Yud with the Aleph, with the Vav, the tree of life between them. The Rebbe Melech Mashiach expressed this beautifully in a 1963 Yechidus with the University of Minnesota Department of Mathematics chairman, Professor Paul Rosenblum, who at the Rebbe's request would eventually complete the mathematical paper conceived by the Rebbe's late brother, Rabbi Yisrael Aryeh Leib Schneerson, the inspiration for this conference. And this is a quote from the Rebbe. There are some who have two sets of bookshelves, one for Sepharim, for holy books, and another for secular books. That is the wrong approach. If a person thinks of secular wisdom as being unrelated to the Torah, he does not understand the Torah, and he does not truly understand the secular subject he is studying. Thus, know this day and take unto your heart that Hashem, meaning Yud Ke Vav Ke, Hu Elokim. Elokim is Gematria Hateva, which means nature, and science is the study of the laws of nature. In the heavens above and upon the earth below, Ein Od Milvado. And all this is merely a preparation for the time when the world will be filled with the knowledge of God as the waters cover the ocean bed. And the Lord will be king over the entire earth. On that day the Lord will be one, and his name will be one. So tonight, I would like to briefly review a bit of the history of the last 100 years or so of this flood of divine knowledge, which is inundating and overturning the Greek worldview of an internal, material, empirical universe. Where we stood before it began, how it has developed since, where it has brought us to today, and where it will be leading us tomorrow. Unfortunately, I only have probably about 20 minutes left, so I'm going to try to make this as short as possible. I'm going to skip a lot of details. I know there are many people who need to speak tonight. Actually, I got a little out of hand. I've got about 50 pages here, so I'm going to do my best to make it short. However, before we start, it is important to define our terms. Ben-Gurion University of the Negev Professor Herman Brandover, who often spoke at this conference, writes that the Rebbe explains that since the Zohar says God looked into the Torah and created the world, the finished product, meaning the universe, cannot contradict the blueprint, the Torah, by which it was designed. The Torah constitutes the only ultimate source of true, complete, and definitive knowledge about everything, including the objects and phenomena which science examines. Torah knowledge extends, so to say, from a perspective of above. Scientific knowledge, in contrast, is obtained by the rational processing of empirical information perceived by the mind through the aid of the senses. Scientific knowledge stems from a perspective of below. Such knowledge is limited and subject to change. Therefore, the Rebbe concludes, the term truth cannot appropriately be ascribed to it. Thus, science cannot truly contradict the Torah, and if it seems to do so temporarily, there must be an error in the science which ultimately will be revealed, although it may take some time to discover it. In fact, this process is exactly what has been occurring. In a letter dated the 28th of Tishrei, 5718, the Rebbe thus wrote, anyone who follows the developments, this is 1957 already, he wrote this. Anyone who follows the developments in the secular scientific world in recent generations will notice that the conclusions of secular science are progressively converging to the conclusions of our Torah. And since then, this process has only been accelerating. So let's take a whirlwind tour through the history of modern physics. Okay, I'll try to make this as fast as possible. So what we call today the scientific revolution can really be divided into two distinct periods, the classical and the modern. Before the turn of the 20th century, science was dominated by Newtonian causal determinism. What this means essentially, I'm just ad-libbing here, is that the Newtonian worldview, first of all, is that the universe is eternal. It's always been here. That the objects in it are solid objects, they're solid particles, that they act according to cause and effect. This basically was elucidated in Newton's Philosophia Naturalis Principii Mathematica, which formulated the laws of motion, gravitation, and classical mechanics, the underlying philosophy of scientific causal determinism. However, the underlying philosophy of scientific causal determinism found its expression in French scholar Pierre-Simon Laplace's 1814 philosophical essay on probabilities, in which he argues that if one could know the precise location and momentum of every particle in the universe, all past and future actions, including human decisions, could be calculated from the laws of classical mechanics. This deterministic worldview, which dominated scientists' understanding of the physical universe for at least 200 years, leaves little, if any, place for a creator, for divine providence, for free will, or even for the soul. Indeed, as English philosopher Samuel Clarke wrote to German mathematician Gottfried Leibniz, the notion of the world's being a great machine going on without the interposition of God, as a clock continues to go without the assistance of a clockmaker, is the notion of materialism and fate, and tends to exclude providence and God's government in reality out of the world. It's interesting to note, though, that Newton did not subscribe to this. On the contrary, even though nominally he was a Christian, he rejected the Trinity as idolatry. He studied Kabbalah and specifically warned against using his discoveries to view the universe as a mere machine. He said, gravity explains the motions of the planets, but it cannot explain who set the planets in motion. God governs all things and knows all that it is or can be done. So the very source, Newton, the very source of this sort of philosophy, he himself did not subscribe to it. This understanding would begin to give way as scientists explored the relationship between light and matter. Light on the one hand, matter on the second hand, and the relationship between two, the relationship between light and matter. So in his hypothesis of light of 1765 and later his optics of 1704, Newton proposed that light was composed of corpuscles, tiny particles of matter, which were emitted in all directions and traveled in straight lines from a source. His reputation helped the particle theory of light to hold sway for the next 100 years. Around the same time, Dutch mathematician and scientist Christian Huygens, missing out on a few. Sorry, this is Herman Brownover with the Rebbe. That's Copernicus. Here's Isaac Newton. Here's Pierre-Simon Laplace, Samuel Clarke, Christian Huygens. Oh, we haven't gotten to Thomas Young yet. Okay, sorry. I forgot about this. I'm not used to doing this. I'm sorry? Yeah. Let's see. Christian Huygens worked out of mathematics. I can go backwards. Here's Christian Huygens. Okay. So Christian Huygens worked out a mathematical wave theory of light, Galim, in 1678, and published it in his treatise on light in 1690. He proposed that light was emitted in all directions as a series of waves in a medium called the luminiferous ether. Huygens' wave theory was lent considerable support by English physician Thomas Young. There we go, Thomas Young. Early double slit experiment at the beginning of the 1800s, in which he demonstrated that light light traveling through, which he demonstrated light traveling through two slits in a screen interfere with each other the way waves would in a pool of water. Okay? If you shine a light through two slits. He said if there were particles, basically Thomas said, if they're particles, you'll just get two lines essentially. But if they're waves, then you'll get a series of interference patterns. And Thomas Young showed that in fact that what you get is something like this, an interference pattern. Therefore, he said, Newton must be wrong and Huygens must be right. So therefore light must be waves. Okay. Later experiments by French physicists Augustin Jean Fresnel and others in the same century supported the wave theory until Newton's particle theory was all but abandoned. All of this led American physicists Albert Michelson and Edward Morley to attempt a series of experiments in 1887 to discover whether Huygens' luminiferous ether existed or not. After all, if you have light, if you have a wave, it has to be a wave of something. You have water. If you have wave, you go to the beach. You have waves at the beach. It's waves of water. You're hearing me now because there's waves of sound. There's a medium through which these waves are traveling. So if the light was traveling, there must be this ether must exist through which the light propagates. So they did a series of experiments in 1887 to discover whether Huygens' luminous ether existed or not. They attempted to measure the speed of light in perpendicular directions to the movement of the Earth, which would be different if light was propagating through a medium such as ether, and found no difference whatsoever in their relative speeds. Just like if you're in a car and you throw a ball in the direction, if you say you're on a truck and you throw a ball in the direction of the truck, if the car is traveling at 100 miles an hour or 50 miles an hour, and you throw the ball at 50 miles an hour, then the ball should be going at 100 miles an hour. If you throw it behind you, it would be basically not, traveling at zero. But they found that no matter what direction they pointed the light always traveled at the same speed. And it was a big mystery. They couldn't understand it. How is it possible? So, where was the ether? Therefore, where's the ether? Meanwhile, English scientist Michael Faraday, who first discovered cathode rays in 1838, had proposed in 1847 that light was a high-frequency electromagnetic vibration, as Professor Simon was saying, which could propagate even in the absence of a medium, such as the ether. Inspired by Faraday, Scottish scientist James Clerk Maxwell discovered in 1862 that self-propagating electromagnetic waves would travel through space at a constant speed, which happened to be equal to the previously measured speed of light. From this, Maxwell concluded that light was a form of electromagnetic radiation, for the first time unifying electricity, magnetism, and light into aspects of a single phenomenon. In 1873, he published a treatise on electricity and magnetism, which contained a full mathematical description of the behavior of electric and magnetic fields, still known as Maxwell's equations. Okay, so that's the story of light. Now let's go back and talk about matter. Meanwhile, with regard to matter, in 1808, English chemist John Dalton was the first to provide, experimental evidence for Leucippus' and Democritus' idea that all matter is composed of tiny, identical, indivisible particles. However, he showed that what differentiated one atom from another was their respective weights rather than their shapes, and they combined in whole number ratios to form compounds. Then in 1827, Scottish botanist Robert Brown used a microscope to look at dust grains floating in water and discovered they moved about erratically, a phenomenon which came to be known as Brownian motion. So basically he put little particles of dust on the water and he saw that they would vibrate. What was causing them to vibrate, even though the water was perfectly still? So he made to think, well, maybe maybe the water is made up of little particles. In 1869, Russian chemistry professor Dmitry Mendeleev published his first periodic table of the elements, demonstrating the periodicity of the elements' chemical properties. And in 1897, English physicist J.J. Thomson showed Faraday's cathode rays to be composed of very light, negatively charged subatomic particles, overturning the notion of the atom's indivisibility. And in 1904, proposed that they were evenly distributed within the atom's otherwise positively charged mass, like plums in a plum pudding, a theory which became known as the plum pudding model. Thompson? Here we go, the plum pudding model. Okay? So basically, he showed that the atom, now remember, atom is from the Greek meaning indivisible. Atom should not be, you shouldn't be able to divide it anymore. But what Thomson showed was that in fact there are particles which are smaller than the atom. That the atom has both positive and negative aspects. So he proposed that basically it was like this, that basically the positive part is the red, and the negative part was the blue, and basically it's like a plum pudding, like a chocolate chip cookie. Okay. 5 years later, in 1909, his student, New Zealand physicist Ernest Rutherford, directed experiments which showed that most of the atom's mass was concentrated in a small, highly charged nucleus, orbited by a cloud of oppositely charged, low-mass electrons, a model he proposed 2 years later in 1911. I don't know if I have a picture of that. Yeah, here we go. Here's the Rutherford model. So he showed that, in fact, that all the mass and the positive aspect of the atom was in the middle, and the negative part of the atom was around the outside. So now the atom became to look like this, which is sort of how most people think of the atom. Finally, so that deals with matter. Okay, so we talked about light, we talked about matter. Now let's talk about the relationship between the two. Finally, the relationship between matter and light began to be untangled between 1859 and 1862, when German physicist Gustav Robert Kirchhoff conducted research on thermal blackbody radiation, linking particular chemical elements with their corresponding unique wavelength-specific spectral patterns of absorption and emission lines. See if I have a picture of that. Here we go. So if you take these various elements like sodium or hydrogen or calcium or magnesium, neon, and you heat them up very much, they start to glow. Now, what you would expect is that they glow. If you put a light through a prism, then you get a rainbow. A beautiful rainbow. But that's not what they found. Here's the rainbow above, right? Instead, what they found is that they got specific lines, specific, color, one of red, one of blue, one of green. You didn't get a beautiful rainbow. Every single element has a different pattern of rainbow. It has a different specific lines. And nobody could explain this. So basically, this is the relationship between matter and light. Here you've got matter, which is emitting light. Why would it be emitting light like this? Nobody could explain it. Let's see. Okay. Austrian physicist Ludwig Boltzmann, who developed statistical mechanics by controversially applying probability theory to describe the average states of mechanical systems, suggested in 1877 that the energy states of a physical system can be discrete, and arrived at an approximation of a distribution law for black-body radiation by considerations of Maxwell's equations. In 1896, German physicist Wilhelm Wien also empirically determined a distribution law of black-body radiation known as Wien's law, but neither of these hypotheses was accurate at low temperatures. So both of them came up with a theory, and both of their theories were wrong. So now we get to the 20th century, and this is where everything begins to change. So up till now, we have a few mysteries. Basically, we live in an eternal universe. The universe has always been here. We've got solid objects. We've got atoms, although we're beginning to understand maybe there's something smaller than the atom. We've got light. We've got some strange things going on, but okay, we live in a solid universe. The universe has always been here. We have cause and effect. We can be safe. We can be comfortable. It's a nice, comfortable world. We don't have to worry about anything. But then everything turned upside down. In 1900, German physicist Max Planck arrived at a theoretical model which accurately predicted Kirchhoff's spectral patterns of absorption and emission lines. Okay? Basically, he said, let me just go on. Several early attempts at a theoretical model had failed, including some early attempts by Planck. And as an act of despair, this is now his quote, as an act of despair, I was ready to sacrifice any of my previous convictions about physics. He turned to Boltzmann's still controversial statistical mechanics. The deceptively simple equation he arrived at, E equals h nu, was based on the revolutionary postulate electromagnetic energy, E, okay, could be emitted only in quantized form, where nu, the V there, that's a nu, is the frequency of the energy, and h is a constant, now known as Planck's constant. So basically what he's saying is that energy, you think of energy as sort of like your volume on the radio, right? You can turn it up, you can turn it down, you can as much as you want, as little as you want. And what Planck said was that no, energy is not constant, it's not smooth. It goes in discrete quantities. You can have 1, you can have 2, you can have 3, you can have 4, but you can't have 1.5. Okay? Just like instead of being a smooth dial on the radio, it's like you've got volume at 1, 2, 3, 4. Mine goes to 11. It's discrete. You have only discrete numbers that it can arrive at. Let's see. Exact. Video. Okay, in other words, energy can only be emitted or absorbed in multiples of an elementary unit, or quanta. At first, Planck considered this quantization was only a mathematical tool. He just thought, okay, the math works out. But he didn't, and this is his quote now, a purely formal assumption. Actually, I did not think much about it. But subsequently, Planck tried to grasp the meaning of energy quanta to no avail. He couldn't understand, he discovered it. It works, it described those lines perfectly. But he couldn't figure out what it meant. Then, in 1905, his Annus Mirabilis, the miracle year, an unknown Jewish-German patent clerk named, you guessed it, Albert Einstein, published 4 papers that started the second scientific revolution. The first paper, published in June, explained what is called the photoelectric effect, why it is only the frequency of the light shining on a material and not its